Welcome back everyone. In today's video we're going to build an HTML smuggling payload. But first, let's do a quick overview of the initial access cycle. It all begins with reconnaissance, using OSINT to house emails, domains, employee names, tech stack, and public facing assets. You can use tools like Maltego, Hunter.io, even certificate transparency logs. Anything that helps us house the target, what is it, and stuff like that. Next, the map attacker surface. In this section, we identify candidates and enumerate exposed services, like web portals, VPNs, APIs. You can use Shodan or Census. Look for fingerprint vulnerable applications. On the vector selection, you need to choose via HTML smuggling or even weaponize an office document or even exploiting a vulnerable service. You can go and abuse leak credential, also an USB drop or even a supply chain compromise. On the payload preparation, we need to generate it with different tools, or you can create your own. You can use MetaPredator, Cobalt Strike, or even a custom that you would like. You can use some obfuscate tools also, even to encode it or use some packers and wrap it into an HTML or even a HTML smuggling page. Also, you can use a macro enabled document. On the delivery section, you can use the technique phishing email with link or attachment, drive by download, or even using the USB drop, or even compromised software vendor. You can use also domain fronting use over HTTPS to hide your C2 traffic. And then on the execution section, the user clicks the link or open the HTAA. The browser reconstructs the payload in memory and launch our reverse shells, all without dropping a binary on even the disk. Finally, on an established foothold, our reverse shell or our beacon calls back to the C2 server. That's our initial foothold from where we moved onto privilege escalation and on lateral movement. And basically that's initial access cycle from recon to activate control. If you found this useful, hit a like, share with your colleagues, and then let's go to the next section, shall we? Finally, let me show you how exactly what we built in today's demo. An HTML smuggling page that delivers a base64 encoded HTA payload. When the victim opens the page, their browser will reconstruct and automatically download an HTA file. Double clicking that file will invoke an exe, launching a MetaPredator reverse HTTPS shell back to our Metasploit handle, all without even writing a raw binary to disk. So let's get started to now let's create the HTA file using MSF Venom, calling MetaPredator reverse shell HTTPS. Basically, that's our RP, the port that we are going to listen, and on this section it specifies the HTA format, embedding a PowerShell downloader stub, and this is just the name of the file. Then we need to convert the same file into base64 so we can embed it into the HTML file. After that, we go to the VS Code. So now here on VS Code, this is the HTA file that we generate using MS Venom without converting into base64. Basically, on this line here, this moves the HT window of the visible desktop so the victim never sees a pop-up. Then we create two COM objects, and this one let us run system commands, and this one let us inspect files and folders. Then this section, the script loops over each folder in PS model path environment variable looking for PowerShell. This ensures we locate the correct PowerShell binary even if it's not even in the default path. And once we find the PowerShell, it runs the payload. And basically, this disables the profile, this hides the window, and that's the payload from MSF Venom. Now here is just the payload converting into base64, and then with this template we invent the base64 code here, and let me explain real quick what it does this section. Okay, so the first step to convert our base64 encode string back into its original binary from, we use the browser's atop function for this purpose. Then on this section we allocate unit A array whose length matches the decode data and populated it with each byte of the binary string. Then we encapsulate this byte of array with a blob, specifying a MIME type of application HDA. This effectively creates a virtual HDL file in a memory. And to deliver the HDA to the victim system, we generate a hidden anchor element, assign its href to the blob or URL, set the download attribute, insert into the document, and invoke a programmatic click. Then on this section, also fallback with data visible link on the page, so if automatically download is blocked, then user may still obtain the file manually. Now to end this video, let's try it, shall we? We just open a server into our machine. Then don't forget to configure Metasploit, setting the payload, the host, the port, and then let's get into our machine. Now that we are on our victim machine, don't forget to turn off Windows Defender. We didn't apply any version techniques yet. We paste our attacker's machine. We double click on our file. Let's wait a bit. Let's take a look at our malware session. We're in. Now to see the sessions. That's our new session. To interact with it, let's type sessions the ID, and basically that's it. We're in. So we create an HTA payload with MS Venom. We converted it to base64 and embedded it in HTML, and this fileless method keeps things quiet and fast. Remember, it's only testing environments where you have permission. If this helped, like, comment, and subscribe for more. See you in the next one.
If you're passionate about malware and cybersecurity, I've got something awesome for you. Check out our academy focused on ethical malware projects. We offer a range of courses to boost your skills. First up, there's Introduction to Windows Malware Development for those getting started. Next, dive deep with building a custom RAT to create your own remote access tools. And for those wanting to analyze and understand malware, there's Introduction to Malware Analysis. But that's not all. We also have our malware development modules, mini courses that cover specific topics like evasion techniques. Join us and level up your skills